Hey guys, so today we're going to go over basic angle pairs, and by going over these terms, it'll definitely give us an advantage to topics later on in geometry, specifically decoding word problems and helping us out with proofs. So let's start off with the first term, complementary angles. So complementary angles are when two angles sum up to 90 degrees. So a simple example of that is this one here, where we have angle 60 plus angle 60 and angle 30, and if we add angle 60 and 30 we do get 90. Another way of figuring out if we do have a right angle is if we have the corner square marked at the vertex point, and by seeing that symbol we can automatically conclude that you're dealing with a right angle, and therefore can be broken down into complementary angles. So let's say we're given a simple algebraic problem where we're trying to figure out the value of x. Well, I can either be given that angle ABC is a right angle, or angle ABD and angle DBC are complementary angles. So if I'm given either one, then I can write an equation, and the equation would look like the following. So it would be x plus 10, representing this upper angle, plus 40 degrees, that lower angle, and we're going to set it equal to 90. This is very important. If we have complementary angles, we always set our equation equal to 90, and then we can solve it as normal. 10 plus 40 is 50, and then subtract 50 on both sides, we get x equals 40. And that's pretty much it for that scenario. So let's say we're not given a diagram, we're just given word problems. If we know the definition of complementary angles, and we can easily figure out this problem here. So here it's saying angle C and angle D are complementary. Angle C equals 2x plus 5 and angle D equals 3x. Determine the value of x. We set up an equation by adding these two and setting it equal to, again, 90 degrees. So we're going to write 2x plus 5 plus 3x equals 90 degrees. We would add 2x plus 3x to get 5x plus 5 equals 90. Subtract 5 on both sides to get 5x equals 85, and then divide both sides by 5 to get x equals 17. Okay, so let's move on to supplementary angles. That's when two angles are adding to 180 degrees. So a simple example of that is 120 plus 60. And 120 plus 60 does give you 180 degrees. If we move on to an algebraic example, we have the following. We have angle 70 here, and then an expression x plus 30 here. If we're told that angle DBA and angle ABC are supplementary angles, or DC is a straight line, then we know that these two will always add up to 180. So then we can write the equation as 70 plus x plus 30 equals 180. And 70 plus 30 is going to be 100 plus x equals 180. 180 minus 100, that will give us 80. So x equals 80. And that's pretty much it. And again, this problem is easy to solve knowing that we're dealing with supplementary angles. So let's move on to the next term, which are vertical angles. Now, vertical angles are angles that are congruent, and they share a vertex point but not a side, and they're directly opposite of each other. So in this example, we have two lines intersecting, and they form four angles. They have an angle here, 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 and here, and you end up having two pairs of congruent angles. These two angles end up being congruent, and these two angles end up being congruent. So in this example, I have 60 here and 60 here. That means these are vertical angles. If I wanted to write this out, let's say you're doing a proof, whenever you see intersecting lines, you can automatically conclude that you have vertical angles. So if I were to write this out, I can say angle CB is congruent to angle DCE. And I want you to notice that they both have the same vertex point. So that's very important for vertical angles. Now, because vertical angles are equal to each other, we won't we won't add anything and then set them equal to something. We're going to just set them equal to each other. So here I have a situation where I have 40 degrees here and x plus 10 here. I'm going to set these two equal to each other and figure out the value of x. So I'm going to write 40 equals x plus 10. Subtract 10 on both sides. I have 30 equals x. Okay, and that's how I can figure out missing the value of a variable given vertical angles. Alright, so you want to again note that when you have complementary angles and supplementary angles, you add expressions together and set them equal to their respective numbers, but for vertical angles, you want to make sure you're just setting them equal to each other. Okay, so let's get to adjacent angles. Adjacent angles are angles that share a vertex point and a side. So an example is something like this, where we have angle A up here and angle B down here, and they're sharing vertex point B and sharing side BD. Okay, it's very important. So let's say you're given a diagram where there's a bunch of angles, and you're trying to determine which angles are adjacent or not adjacent. So here I see that angle 1 and angle 2 both share vertex point C and side CG. So I can write angle 1 and angle 2 are adjacent, if I wanted to point that out. Now, which angles are not adjacent? Well, clearly the angles that don't share a side, because here all three angles are sharing the vertex point. So I can say angle 1 and angle 3 are not adjacent, because in between is going to be angle 2. So angle 1 and angle 3 are not adjacent. Okay, so knowing the term adjacent is important, especially when you get to supplementary angles. So there's two ways of looking at supplementary angles. You can either look at it when it's connected like this, or when it's disconnected, let's say like this. Let's say there's a space in between here, and I have another angle here, and this is 60 degrees, and this is 120 degrees again. Okay, these definitely would be classified as supplementary angles because they still add to 180. Now, there's a special term applied to supplementary angles that are adjacent, and those are called a linear pair. So a linear pair are supplementary angles that are adjacent. Alright, so supplementary angles that are adjacent. So this is an example of a linear pair as well as supplementary angles, and this is just an example of supplementary angles. These two terms, they kind of interchange, but I guess it becomes a bigger deal when you're taking the regions where they kind of want you to know the difference between them. I don't know, you'll probably see that in a multiple choice, or you'll see that as part of a short answer problem. But just knowing that a linear pair is the same thing as supplementary angles, except that they're connected, is good enough. And then you would just solve the equation that you set up as normally, setting it equal to 180 and whatnot. And that's pretty much it. We'll definitely see more of these terms when we are going through proofs and solving word problems and whatnot. So if you have any questions or comments, leave them in the comment section below, like and subscribe, and I'll make another video later. Bye!